Hello everyone, it's Christina, and in this video we're continuing with our A-level maths paper 1 from 2018, and this is the Edexcel board. We're looking at question 6 here, so let's have a read through and see what we can start with. So we have a circle here, we have an axis plotted with circle C, and the center A has coordinates 7, 5. The line L, which is this line here, has equation y equals 2x plus 1 and is at a tangent to C at point P. So it's a tangent to our circle C at this point. Now for part A, we want to show that the equation of the line PA is 2y plus x equals 17. So let's jot that down. So that's our PA. So if we maybe extend that, so we have a straight line going through it. PA itself is the radius of the circle, and we know that if we have a line which lies at a tangent to a point on the circumference of the circle, then the radius of that circle from the point at which it lies at a tangent to the center, which in this case is A, so from P to A, is perpendicular to the tangent. So then we can mark this as a right angle. Okay, so then we know that PA is at a right angle to the line L. Now, if that's the case, that means that if we can find the gradient of our line L, let's call that M1. So that's the gradient of L. And then if we can also find the gradient of PA, let's call that M2. If PA and L are perpendicular, which we know they are, then we can say the gradient M1 multiplied by M2 should be equal to -1. Okay, so what's useful here is we have a way of finding the gradient now of the line that goes through PA. So let's start with that. So if we have line L, y equals 2x plus 1, we can directly read off the gradient of L. So M1 is equal to 2. So now let's plug in that value with our rule that we have here for our gradients. So that means that if M1 is 2, 2 times M2 equals -1. Therefore, M2 equals -1 over 2. Okay, so that becomes the gradient of our line PA. So if PA takes the form, I'll just write PA here. So imagine PA takes the form of a straight line, right? So it's going to be y equals mx plus c, but we know that its gradient is -1/2. So it means y equals -1/2 x plus c. So the last thing we need is we need our plus c, our constant. We are given the information that A has coordinates 7, 5. That means A here has coordinates 7, 5. And so the coordinate 7, 5 actually lies on the line, meaning we can substitute in the value for x and y into our straight line equation here, and then we can get a value for c. Okay, so let's have a go at doing that. So at 7, 5, this becomes, and all we're doing is substituting in x equals 7 here, and y equals 5. So we get 5 equals minus 1/2 times 7 plus c. That's 5 equals minus 7/2 plus c. Therefore, if we're solving this linearly for c, we can just say c equals 5 plus 7/2, because we're moving that minus 7/2 onto the left-hand side. And so we can just add them up now and leave it in a fraction form. So 5 plus 7/2, we can rewrite 5 as 10/2. And then if we have 10/2 plus 7/2, we get 17/2. And that's our plus c. So our line PA has equation y equals minus 1/2 x plus 17/2. And now let's make sure that we get it in the form that is required. So all we need to do that is multiply each term by 2. So if we do that, multiply through by 2, we get 2y equals minus x plus 17. But then we can see the x is on the left-hand side. So all we need to do is add x to both sides. Or you can think of it as moving your minus x onto this side and changing the sign in front. And so we get 2y plus x equals 17. And so we've shown part A.